Implementation of data anonymization technique using masking and k-anonymization. This experiment focuses on implementing basic data anonymization technique using Java to demonstrate how sensitive information can be protected in a real-world application. The aim of the experiment is to implement the basic data anonymization techniques such as data masking and k-anonymization technique on a simple dataset using Java in order to protect the sensitive personal information from unauthorized access. Why this experiment is needed? In today's digital world, organizations frequently collect and store sensitive user data such as names, email IDs, and credit card numbers, medical records, bank details. If the information is exposed or leaked, it may result in identity theft, financial fraud, loss or user trust, privacy violation. To prevent these issues, data anonymization techniques are applied to ensure that the sensitive information is hidden or transformed in such a way that individual cannot be easily identified. At the same time, anonymized data can be used for testing and analysis the research purpose only. This experiment helps us to understand how anonymization works at a practical programming level. First, we need to explore masking programming. In first line, import java.security.message.dz. This line imports the class from a Java security package. It is used to perform the cryptographic hashing, specifically secure hash algorithm 256 in our program. Hashing is the important because it converts the sensitive data into fixed length of encrypted format that cannot be reversed. Then we create a class as a class name as the masking. It identifies the class named using the masking. In Java, every program starts with a class. The class name usually represents what program does. Here it performs the data using masking. Then we put public static void main string args throws exception, handles the possible errors during the hashing. Without this method, the program cannot be run. Then we give a original data sets, that is the sensitive information, string name and email and credit card numbers. This variable stores the original sensitive data. This simulates the real user information collected by application. It examples in a real use the hospital patient name we consider it, and user email in a website we consider it, credit card numbers in e-commerce apps we also consider it. Masking the name. We try to mask the name as XXX. We put in a name dot character of first letter to last letter. First character to last character of the name. This replaces the remaining character as X. This keeps the minimal identity while hiding the full information. The original name will Harini Murugan mean. The masked name will HXXX continues to last character. Hashing the email. We try to hash the email. Stored it in email hash equal to hash lib skha. This is the algorithm of secure hash algorithm 256 of email dot substring of when the start is 0 and end with we don't know the last character, so we put it on the 0,20. Then we masking to the credit card numbers. Credit card equal to star star. We put to mask on the numbers in a star symbol. Credit card dot substrings of credit card length of -4. Then all digit except the last 4 digits are hidden. This is the standard security practice. Then we displays the results, the data masking results. This line prints the original and anonymized data. The system.out.println data masking results, original name and masked email and masked card. Then helper method for hashing. That is the method of private starting string hash lib of skha 256 of string data throws the exception. This method takes a string input and returns the skha 256 hash. Private is used only inside the class will be accessed. Static, the no object needed to call it. We creating a skha 256 digest hashing the algorithm instantly. skha 256 produces the 256-bit secure hash. Then generating the hash bytes. It converts a string into bytes. That is, we give input in a string that it converted into bytes. Applies the hashing to generate encrypted bytes. Then converting bytes to hexadecimal, that we are need for credit card numbers. Converts the byte data into readable hexadecimal format. Hexadecimal is easier to store and display. Then returning the hash value. Then return xstring dot toString of. This returns the final hashed string into the main method. It goes to main method. This is the program of data anonymization technique using masking. Real world application, it is used in banking systems and healthcare records and government databases and cloud data security and etc.